Good morning. I'd like to welcome you to our digital classroom. I'm Jerry Winslet along with Kenneth Ezell, and today what we're going to be talking about is power vent water heaters. We're actually going to be talking about a couple of different power vent water heaters. The new 0.70 standardized power vent, and then we're going to talk about the older style, the intelligent gas valve style water heater, power vent water heater. How we're going to do this, though, is we're going to talk about the water heaters and kind of how they work and some of the parts that kind of separate them apart from each other, you know, the differences between the two. And then we're going to go over to a water heater, to a new 0.70 water heater. We're going to talk about sequence of operation, and then we're going to get into what we really want to know about is troubleshooting. And what we're going to do, we're going to troubleshoot. We're talking about about 80% of what they're going to see in the field if they work on these water heaters. This is about what you see most of the time. It really boils down to about 3 different codes.
Yeah, the most common codes that you would typically see.
Yep. So let's go ahead and get started. We got a lot to do. First off, when we're talking about power vent water heaters, we make many different styles of water heaters. Why would somebody want to go with a power vent water heater as opposed to, say, a standard atmospheric or another type of water heater?
Well, usually with the power vent, it offers more venting versatility. With an atmospheric vent water heater, it has to vent through the roof, using typically expensive B vent, which is kind of high price, right? But with the power vent, you can get away with using PVC. So, and you can go, the distances you can go are a lot further, plus you can either vent it from a sidewall or out of the roof.
Oh, that's a lot better. So really, we can put these in places we can't put a standard atmospheric water heater.
Correct.
All right, so, you know, and it also, I mean, there's a lot of advantages to that. You know, since we're able to do that, we can actually run the vent a lot longer, like you said. So you can put it in one side of the house and you know, vent it a lot further than you could a standard atmospheric.
Yeah, usually with an atmospheric vent water heater, you may be going 10 to 12 feet out of the roof. But with the power vent, depending on what size venting you use and how many elbows and everything, which we'll kind of talk about, some of the models you can go to 180 feet.
Yeah, and that's one of the big things about the new 0.70 is we can vent a lot further than we could with the older style.
Yeah.
All right, so now let's go ahead and talk a little bit about some of the differences that kind of set this apart from the old. The first thing I want to talk about, because we have it right here on the desk, is the gas valves. They are different.
Yeah, the gas valves are different. The new version of the power vent uses the Honeywell control valve. And you can see it definitely looks a lot different. One thing that's different is the way we deliver status codes or error codes. The Honeywell valve has a single LED light that will flash a code at you. It gives multiple flash codes, whereas IntelliVent has 6 LED lights that goes across the front, which can give us an error code of usually it's going to be 2 or 3 lights lit up, but also that's also the lights we use for our temperature adjustment. Honeywell has a standard temperature knob, so I mean it's pretty easy to see what temperature it's set to.
Now with that IntelliVent valve, I know that when the water heater's working properly, no lights are lit up at all, correct?
Correct on the IntelliVent, if everything's working fine, you have no lights lit up. Whereas on the Honeywell, you have a couple of different status lights that tells you everything's working. So this one you know you have when it has power, you know when it's heating water or should be heating water, but I mean you also know if it has an error code, which isn't different from this one, but definitely you know if it has power and you know if it's calling for heat.
Is the way we sense temperature any different?
It's kind of, both of these control valves use thermistors. They're just encased in a different type of probe. Whereas the IntelliVent valve uses a copper probe like old school mechanical valves.
Yeah, it looks like a rod and tube actually.
Yeah, it looks like a rod and tube probe, but it actually has a thermistor in it. The Honeywell has a thermistor also. So they both really, they control temperature very accurately because using a thermistor. It's a lot better than a rod and tube style, but they are both using thermistors.
Okay. All right, the next thing I want to talk about is one of the major changes that we had. It's a certain part on the heater. Is the blower. The blower did change. We went with a different style of blower, and there's a feature on this that kind of is really cool. I don't know how you want me to set that there.
Yeah, we are using a blower. This blower not only is it more quiet than the blower on the older style power vents, it's also more powerful.
Okay.
And so we can vent it a lot further. Another great option about this, and we were talking about venting versatility earlier, the blower is actually rotatable. You can rotate it. So I can take this out and actually turn the blower. As you see, it can be in this orientation, or I can turn it and put it in this orientation.
So you just got 4 bolts on the back that...
Correct. I have 4 bolts on the back that allow me to rotate it. But this is an excellent option if you have installation that that has low overhead clearance. I can normally on most power vents and most of the water heaters this thing's going to be replacing, the venting comes right out of the blower, right out of the top, right? And so you have, on a lot of older power vents, you have to come up a certain amount of footage or so many inches before you elbow it or do anything like that. Yeah. But on this heater, I can actually avoid that turn because I can turn the blower either way and it's already going maybe in the right direction.
And you're saying that this is more powerful, so that's the reason why we're able to get 180 feet with this water heater as opposed to the older style, which is what, 120? Correct.
Most of the older heaters, there were a couple of models that were 160, but yes, we can go 180 and do it a lot quieter.
Okay, and this is a normal blower. We still use a blower prover switch, which is a switch. It's a normally open switch that closes on a rise in pressure or a drop in pressure, whichever one the switch. You know, the switch is the way the switch is made or designed for is to prove that the blower is running. So whenever that switch sees that pressure, whether it drop or raise. Those contacts that are sitting in there, they're open contacts. When that blower kicks on, the pressure from the blower closes those contacts and allows that electricity to pass through it. In line with that is you still have a high vent temperature switch. Now the only reason why I'm saying that is that's the switch activation point is a lot lower than it was on the older style.
Correct, and this one's actually a normally open
right
switch.
Here, sorry.
Yeah, the air pressure switch on this water heater or the blower prover is actually an open switch that closes on a fall in pressure when the blower creates a vacuum when it turns. But wired in series with that switch or in line with the switch is a vent temperature high limit switch that ensures that if something was to happen, if the blower was to get too hot, it would not melt the venting. It'll shut the water heater off. But the reason to know, or the important reason to know why they're wired together is this, because if one opens, they're wired together, the control valve is going to see it as the same thing.
Right.
It's just going to give you one code. It cannot differentiate between whether it's the vent limit switch open or the blower prover switch open. And so you have to be able to check them both. So you don't want to forget about it.
That switch will actually open up at 145 degrees.
Yeah, on typical models like this one, it's 100. That this blower would come off of it, it's 145 degrees.
Yeah, because we have to keep those flue temperatures low because we're using PVC, correct?
Yeah, we are using PVC, and PVC, it's plastic pipe, it can only handle so much heat. So it's a safety device to ensure that we don't cause any damage to the venting.
Okay, and all of these, you know, your blower prover switch is actually there's a cover which we'll talk about when we go over to the other heater, but covers all of these components here. But there's another thing I want to talk about on this blower. There is a blower capacitor, and I've got one right here. Before, if the capacitor was bad on a blower with the older style, we would have to replace the whole blower. Now this comes with a separately replaceable capacitor.
Yeah, the newer blower motor comes with a separately replaceable capacitor. So if you're ever an issue, or say you were getting an error code where the blower was supposed to be running, but it's not, on the old school heaters, you had to replace the whole blower. You know, if you tested and you had power and the blower wasn't started. But on this one, we have this capacitor, and it's something you can replace, by itself. You may not be able to go to your supplier and find one that looks exactly like this, but as long as you find one that's rated the same, this one I believe is rated 3 microfarads. Yes. If you find one that's rated the same, you could at least get the heater back up and running until you can get the correct one that fits, that tucks into the blower and looks nice.
Yeah, so I mean, that's great for service. So if the blower won't start, normally with the older style, you'd have to replace the whole thing. Now we can just replace the capacitor. You can have one on your truck. Instead of pulling it off of the water heater, just unplug your leads, plug it into this, try it out. If it works, then go ahead and replace it.
Correct, and most suppliers carry capacitors because several electric motors use these.
Now, another thing that's changed on this water heater is how we're bringing in air. whereas before with the older style, we were pulling it in on the bottom like a normal water heater, and then even a standard atmospheric water heater. We pull in air at the bottom. With this water heater, it's kind of changed. We're actually bringing air in a lot higher up on the water heater.
Yeah, on this water heater, we're actually using what they call a vade assembly, which is a snorkel or air intake, and here's a piece of it. Jerry's getting the other piece.
I get the other piece up, sorry.
It goes like this, all right? This thing actually bolts to the back of the combustion chamber.
Actually, I have a combustion chamber right here.
We can show them that.
We'll do the whole thing. Now all I need is a tank and water and we'll be good.
Yeah. All right, and so this actually bolts to the back side of the combustion chamber right here, sort of like so. All right, and when we do this, we're bringing our combustion air up several inches off the ground, right? And so if we do that, the heater actually doesn't have to have a flame arrestor, which is good because you have a lot less maintenance. So since we're using this, the heater does not have to have a flame arrestor, and so actually the heater is getting cleaner combustion air, but also it's less maintenance because you don't really have a filter you need to clean too much.
Now, I mean, what if you, since it's on the back of the water heater, if I put it up against the wall, is that going to make any, I mean, are we going to cut these louvers off? Is that going to be a problem?
Well, the thing is this vade assembly or snorkel assembly is curved. So yes, if you fit it into an unfinished wall, you do have the potential of blocking off these back intake vents right here. But the good thing about it is it's also open right here on the other side. I can pull it off where you can see. It's open on both sides. It's contoured to where it fit up against the heater. And so it's still going to get air. Even if you put this, block this up with insulation completely in an unfinished wall, it's still going to be able to get combustion.
Yeah, because it sets off the water heater about an inch or so.
Yeah, about ½ inch or an inch or so.
Wow,
So,
okay.
yes, we're still going to get air.
All right, so that's how we're taking in air. Since we have the combustion chamber up here, we can talk a little bit about the burner and the ignition system. The first thing that looks different on the burner is we've got a little hole there. What's the hole for on the burner?
Well, this is a more efficient power vent. It's not a condensing power vent, but it is more efficient. And with a Category 3 appliance like this, some condensation is expected,
right?
Especially when the heater fires off. So on a typical burner, you have this little dip right here to catch condensation. Just this little bowl right here that you see. But with this heater, since maybe a little bit more condensation can happen, or it can condense a little bit more, we have a little drain hole right here to where it will drain it down and just burn it off on the radiation shield.
Okay.
So that's one good thing. Like I said, it's not really a condensing heater, but it is more energy efficient, so you might get a little bit more condensation than you would compared to the older power vent water heaters.
And looking at the inside of the combustion chamber, and I know we can get an overhead shot of this, it's a little bit different as well. You got all these holes here on this plate. Does that have to do, obviously it has to do with airflow. What's the reasoning behind that?
There's actually a couple different reasons behind that. I mean, depending on the way the water heater gets air, the holes closer to the vade assembly are going to be smaller. That way they meter the air because you'd have more air right here.
Right.
But just like with anything that moves air, right? Even the duct work in your duct work in your house, right? The closer the vent is to the main unit, you would have the dampers in it closed more. The further away they may be fully open. Same sort of deal right here, right? The closer we are to our source of combustion air, the holes are smaller. When we get further away from it, the holes get bigger. And a lot of this just helps with a smoother light off, a nice clean burn, the way it's delivering air and everything. Of course, we have a big hole directly up under the burner that you can't really see. Another thing that helps us with smooth light off is the orientation of the igniter and the flame rod.
Now we're still using a silicon nitride igniter on this unit, and what do you mean the orientation? We've positioned it differently than we did in the past.
Correct. The positioning of the old school power vent, and you guys servicing this would be very familiar with it, just pretty much points straight out towards the burner. Right. We've moved them like this, which it's just going to allow a smoother light off. It actually helps some with condensation falling on it and everything because it's harder for it to hit if it's pointed up. And so you have a couple of different things there, but it just overall helps the way the heater lights off and it's going to operate.
And nothing's really changed about how they operate. We still They still operate, they still warm up for 17 seconds and then we dump gas in there. When we ohm these out, when we're checking these, are these still 46 or so ohms?
Well, this is actually changed. On the older units or the IntelliVent units, the hot surface igniter would ohm to usually 11.5 to 18.8 ohms at room temperature. This is a silicon nitride igniter, just like that, but the difference is this one ohms from 42 to 76.
Okay, 42 to 76.
And then the flame rod's a flame rod.
Okay.
I mean, it's a rod, right? It's just a wire there to prove that we have a flame burning. Another thing I will add, and I'm sure you were going to ask me about it, but I'll go ahead and answer it. They are separately replaceable.
Yeah, that was what I was going to say. Whereas before you could, when you had to replace one, you had to replace them both. Now we've got this where we can replace one or the other.
Yeah, you can replace one. In a lot of cases, silicon nitride igniters barely wear out. They're pretty robust. They last a long time. But flame rods, you could clean it a lot, or say you accidentally damage it as you're cleaning it. You had to replace the whole igniter assembly on the older style water heaters, right? For just pretty much a cheap part, or a part that was a lot lower cost.
Yeah.
But with this, we can just change the flame rod, and it just connects to the hot surface igniter assembly with a flag connector or a flag connector. So it's pretty straightforward to replace it if you ever needed to.
Okay. All right. Well, what we have next is I've got one other thing I want to show them, but it's actually on the water heater. So what we're going to do is we're going to go over to the water heater and talk about it, and then we're going to talk about the sequence of operation, and we're going to talk some troubleshooting. So come with me and Kenny. There is a change, and it has to do with the flammable vapor sensor. I know on the older models it was in the front, it was on the bottom, it was close to the ground. This one's changed. We've got a different location.
Yeah, on the flammable vapor sensor, we actually moved it up on the heater. On the old style, it was right at the air intakes at the bottom of the heater.
Right.
We moved it up on the heater some. We actually put a little black screen over it, or like a cover. And what that does, that helps prevent from accidentally getting wet. Like say you're mopping around the heater, or a pipe was dripping on it. It kind of helps prevent that, to help nuisance lockouts or to prevent damage to
somebody mopping around it, it might hit it on accident. But it's still the same thing. It still reads the same. Here, I'll get it. It still reads the same readings and all of that.
Yep.
I mean, is it?
It's all still the same.
Okay. All right, and we're going to kind of talk about that when we get into troubleshooting, because that's one of the troubleshooting errors that you might experience when you're in the field. Okay, so the next thing I want to talk about before we kind of get into the sequence of operation, we deal with working on these water heaters. One of the things that we want to do is check, make sure that the installation is correct. Is there anything we need to keep in mind whenever we're putting these in? And it'll help when we're doing troubleshooting as well, because we can check the installation. What are some of the points we need to think about when we're putting these in?
Well, this is a little bit different from a regular power vent in a couple of ways. It pretty much hooks up like a regular, in any power vent water heater, cold water line, hot water line. You have to have a 120 volt outlet for the wall. Typically, we recommend it's on its own dedicated circuit and that nothing else is plugged in with it.
Okay.
Venting's typical for a power vent PVC. That's something you shouldn't ever really reuse a previous power vent's venting.
Right.
You want to take the time to change it, because number one, PVC's cheap.
Right.
It's not cheap, but it's less expensive than any other vent material. So you want to change it. And one of the reasons why is because every power vent's different. The venting specs are not the same on every single one. And so a newer power vent, especially this one, the venting requirements is a little bit different than an old power vent. And one of the other differences, I think you actually have them.
Yeah. Some terminations here.
It's termination screens.
That bag actually comes with the water heater.
Yes, bag comes attached to the heater. In the past, your termination screen that pretty much all power vents came with, if I can get one of them out.
There you go.
Not that one. But they would just come with a rodent screen, like what you see here.
Can I help you?
They would come with a rodent screen like that. It's just nothing more than a stainless steel screen. Some of the other terminations this one comes with now is like this one. For a 4-inch vent run, I believe it's like typically under 50 feet. 4-inch, you would use this screen.
Yeah,
But
because you got to build up some more resistance, right?
Yeah, you need back pressure. We also need it to meet efficiency. You know, for this heater to have 0.70 energy factor.
Keep those flue gases in. Yeah.
And so you have several different terminations, which is a change from the past. Always refer to the manual to make sure you're using the right termination and that you're following the vent tables that's in the manual, because you don't want to vent the heater outside the parameters of what the manual states.
Yeah, and those termination guidelines are in the manual. They have
Correct.
diagrams. They show you what the termination is supposed to look like, the cap. Make sure that you're putting the right termination on the right vent length or the right size vent. And that's something, because that has to do with troubleshooting as well, because we have to have that in order for the water heater to operate properly. And we're going to kind of get into that when we get to troubleshooting. All right, so next what we want to talk about is the sequence of operation. This is one of the most, or the most important thing you can remember whenever you're dealing with troubleshooting. If you understand the sequence of operation, you can work on the water heater because you know what happens next. Usually if it didn't get to that point in the sequence of operation, you take a step back and you usually find that.
Correct.
So it's in the owner's manual. I would learn every sequence of operation on any water heater that you're working on. So let's talk about the sequence of operation on this one. I'm assuming the first thing that has to happen, you got to have a call for heat.
Yeah, the first thing that has to happen, you have to have a call for heat, meaning it needs to kick on and heat water. And so first thing that happens, it's a call for heat. And then the next thing that happens is that the control valve, which is like a computer, it checks for the proper positioning of certain switches.
Okay.
Which one is your air pressure switch or your blower approver switch. The other is the vent limit switch.
Yeah, and those two are tied together, so it's just looking at that circuit.
Correct. It's looking at the circuit to make sure that it proves open, to make sure no one's bypassed it or anything. And then after that, it energizes the blower, so the blower should start, and then the pressure switch should close on a fall in pressure.
Okay.
And your limit switch is normally closed, so it's already closed.
Okay.
But once that happens, once the switch closes, the heater starts the ignition sequence, which means the igniter is going to warm up.
Okay, and then it'll warm up for about 17 seconds. And then the next thing that's going to happen is the gas valve is going to open up. And when the gas valve opens up, it dumps gas into the combustion chamber. And then you have about 4 seconds to see the flame. It lights the burner. It has 4 seconds to see the flame. Once it sees the flame, then it just starts heating the water.
It's going to, once it proves the flame, it's going to heat water unless it loses the flame or switch opens or something like that.
Okay, and then it'll come up to temperature. Then the burner then goes off. Your blower is going to continue to run for a little while to get the combustion product out, and then the water heater goes into standby.
Correct.
So one more time real quick. So you have a call for heat. The first thing and this happens very quickly, the gas valve checks to make sure that the blower approver and the high vent temperature switch are in its correct state. That means the blower approver switch is going to be open. The high vent temperature switch will be closed. Once it sees that, it kicks on the blower. The pressure from the blower then closes that blower approver switch. That makes that complete circuit. Once it sees the circuit, then the igniter will then warm up for 17 seconds. Then once it reaches 17 seconds, the gas valve opens up. We dump gas into the burner chamber. We light the burner. We have 4 seconds to see that flame. Once we see the flame, we start heating the water. We come up to temperature. The gas goes off. The blower continues to run for a few seconds, and then it goes into standby.
Correct. And anywhere it stops in that sequence of operation, that's when you're going to display a code.
Yes.
That's when we're going to get a status light or air light saying something's wrong.
It's funny you should mention that, because that's what I want to talk about next is troubleshooting. And really, you know, understanding the sequence is going to help you with troubleshooting. And what we're going to talk really about today is about what you see most of the time whenever you're working on water heaters.
Yes.
About 85% of the time, you're going to see around 3 different things sometimes. And it could be on new installs. It could be in there for a little while. But really, we've got call centers here, and we take a lot of calls on all of our products, so we have an understanding what's going on in the field. And really, it boils down to 3 things what we're going to talk about today. And this is true for both heaters, for the older style and the new style.
Yes.
So the first one we're going to talk about is an error code 3. It's a 3 blinking lights.
Yeah, it's going to be a 3 flash on the Honeywell controller or on the IntelliVent. Let me get one. So it's going to be a 3 flash on the Honeywell controller, But on the IntelliVent control valve, you're going to have the warm light lit up or the vacation light, the triangle, and the C light.
Okay.
Both of these codes, whichever way it's delivered to you, whether it's Honeywell or this, it's telling you that the air pressure switch didn't close.
Okay.
And so the heater did not go on with the sequence, in the sequence of operation to heat water or anything. It stuck at that point.
So that means that we're at the point when the blower is supposed to kick on and close the pressure switch. It never saw that.
Correct. Correct. It never saw the pressure switch close, which it proved open. It just did not close.
Okay.
And so first thing I always check for, and this is where the heaters differ just slightly.
Okay.
All right. First thing you want to check to see is if the blower motor's running.
All right.
On an IntelliVent, the older style valve, the blower should be running continuously. If it's not running, you have another problem. On this heater, it's not going to be running because when this heater finally, on the Honeywell, when it finally codes out on this code, it allowed the blower to run for 30 seconds and then it kicks it off.
Okay.
And so first thing you want to check for is if the blower motor's running. If it's Honeywell, cycle power off, turn it back on, see if the blower starts. Okay. On the IntelliVent, if the blower's running,
yeah, you'll just see it running. So.
Yeah, you would hear it and see it running.
Okay.
And so that's the first thing to check.
So okay, so I come up there, I turn it off, turn it back on, and on a Honeywell, I'm going to be listening for that blower to kick on. And what if it doesn't kick on?
If it doesn't kick on, the first thing I do is change the blower capacitor on the Honeywell because capacitors can fail. It's very rare, but the good thing about this is most of the time if an electric motor doesn't start, it's the capacitor.
Right.
And so since this one's separately replaceable, replace the capacitor.
Okay, so if it doesn't start, I'm going to go ahead and replace that capacitor, and then it should start. Now, what if I walk up to it, turn it off, and turn it back on, and I've got an error code 3, so I turn it off, turn it back on. The blower starts, but I continue to get that code, that 3 code.
Well, the first thing I like to do is simple visual checks, right? Anytime I'm troubleshooting a code where the air pressure switch is not, closing as it's supposed to. So I check stuff visually. First thing I check is my sensing tube.
Okay.
To make sure my sensing tube's hooked up, right? It needs to be hooked up on both sides. I make sure I don't see any damage to any wiring, which is kind of hard to see on the newer units. All the wiring's enclosed in here. Shouldn't be a problem, but I like to double check it. So I check the wiring, check the tube. Next thing is one of the most important things. I check the venting to make sure the heater's vented properly per the manual. So make sure your distances between elbows is right. If it states that there has to be a certain distance, make sure your equivalent length is correct because a lot of people forget that elbows count as feet.
Right.
Right?
Yeah.
In a lot of cases, a 90-degree elbow, if it's just a 90, it could count as 5 feet. A 45 counts as 2.5 feet. And so if you can only run this heater 20 feet, but use 190, that means you can use 15 feet of straight pipe. Some people will think, well, I can use 20 feet of pipe, then the 90. That's not the case. It will not close the switch.
Okay.
And always while you're checking the venting, also make sure you're using the right termination screen on this one, or at least the right termination.
Okay. Is there any way to check? I mean, because in some cases it could be the switch itself.
It could be the switch itself. So usually what I'd recommend, after everything checks out and I'm sure my venting's clear, that there's nothing in it, I'm sure it's within spec per the manual, I kind of keep it simple. Next thing I check is blower vacuum.
Okay.
But I have to know what the switch activates at. So I remove my cover. I can actually look at the pressure switch on any of our power vents, and it tells you how much vacuum's required for that pressure switch to activate. And so if I remove the cover, look at the switch, and the switch says it activates at negative 0.27, like on this model, right? That means with the digital manometer, I have to see how much vacuum my blower motor's pulling.
Okay.
If it's pulling more vacuum than it's needed to activate that switch, switch is bad. If it's not pulling enough vacuum and my venting and everything's good, then the blower motor would be bad.
Okay. All right. So go up to it, turn it off, turn it back on. If the blower does not start, I'm going to try a new capacitor.
Correct.
If the blower does start, then we start getting into checking our venting, checking all the hoses, the connections, make sure the switch is connected properly, your high vent temperature switch is connected properly. Then we're going to go ahead and check our pressure. If the blower is pulling enough vacuum and your venting is correct, then that's the switch. If it's not and your venting is correct, then we're looking at maybe the blower.
And there's a couple other things to keep in mind. You also have to always remember that your vent temperature limit switch or high limit switch is on that circuit too and can be responsible for that. So you always want to make sure the switch is closed.
Okay.
Meaning that it has continuity or the contacts in it are closed. And I will add one other thing that we didn't talk about, because since we're talking about two heaters at once, is if the blower doesn't start on an IntelliVent water heater, you actually have to check power going to the blower. So you have to check power going to the blower. You have a 6-pin connector that plugs into the junction box on the blower. You check between the two center pins, which is 2 and 5, and you should have 120 volts. If you have 120 volts and the blower doesn't start, the blower is bad. If you don't have 120 volts, typically that issue is going to be in the control valve. So just to add that, I know it's kind of confusing to do two at once.
Yeah, and I wish we had another heater here, but unfortunately we do have the .70 though. Okay, the next thing I want to talk about is a 6.1 error code or an ignition failure. Now this is typical on maybe on a new install. That you might run into something like this. That means that the water heater tried to fire but never could.
Correct.
So if I walk up to a unit and I see a 6.1 flash on my Honeywell gas valve, what am I supposed to do first?
All right, 6.1 flash, like you said, it's telling you the heater tried to light and either lit or it didn't, you know, or it may have lit, didn't prove that it lit. But first thing I want to do is cycle power off, cycle power back on, and check to see. I have to look through the burner chamber. I'm going to see the igniter glow, but I'm looking for something special. I'm looking to see if the flame ignites after about 17 seconds.
Okay, so it's either going to light or it's not, right?
Yes, it's either going to light or it's not.
All right, what if it does light, but then it goes immediately out?
If you get a burner flame for around 4 seconds and it just turns automatically back off, I'd usually it's going to be something electrical. In this case, it's going to be flame sense. Typically, a dirty flame sensor is not able to conduct that signal.
Okay, so I'm going to go ahead and clean that. What am I going to use? I'll probably use some steel wool, fine grade steel wool.
Yeah, use fine grade steel wool. Just polish up the rod. Make sure when it does ignite that the rod's burning in the flame. It should be, but that's usually it.
All right. What if I walk up to it and I don't see a flame? You know, it tries to light. We see the glow for 17 seconds, and then it just goes out. I never do see a flame.
If you don't see a flame, then I'm usually going to go down the gas road.
Okay.
Maybe the heaters, it could be several different things, but typically it's going to be gas coming to the heater. Just check to see if you have gas coming to it.
Okay, yeah, and that could be closed valves upstream. It could be air in the gas line, because that's one thing that happens on new installs, is you might have a pocket of air in that gas line. So you're going to need to bleed that air out to be able to get it to fire.
Yeah, and you're going to have a new install, you're going to have a large pocket of air in the gas line. So the heater, before it goes to that code, it's going to try to light 3 times. And if it doesn't light, you may have not have got all the air out of the line, so you may have to cycle power off, turn it back on to reset it. But yeah, new install, you're going to have a lot of air.
Yeah, that's why it's probably 3 times is they account for that. They know that's going to happen. So they typically have it that long, you know, get you to try it 3 times so we can get it lit. All right, so on a 6.1 error code on this unit, I'm going to come up to it, turn it off, turn it back on. I'm going to look through the sight glass.
Correct.
All right, so I'm going to look and I'm going to see that glow. I want to see the igniter warm up. It's going to warm up for 17 seconds. If I see a flame and then it goes out, I know that I'm not sensing flame. So I'm going to go ahead and pull my my flame sensor out. I'm going to go ahead and polish that up, put it back in there. If there's damage to it, you can go ahead and replace it. And because it is separately replaceable, I don't have to replace the igniter as well. I can replace just the flame rod.
Correct.
That's great. Now, if I go up to the unit, I don't see a flame and it tries 3 times and then goes out. If I don't see a flame, then I know it's something to do usually with gas. So I'm going to go down the gas road. I'm going to go ahead and make sure that I have nothing's closed off. My shutoff valve's not off. I don't have air in the gas line. I'm going to do whatever I have to do to get that gas to the water heater to get it to work properly.
And everything that we've said about this code, the 6.1 on the Honeywell, is also true for error code 6 on IntelliVent, which is signified by the vacation light, the A and B light lit up. So your first light, and then I believe it's going to be your 4th and 5th light.
Right.
So vacation A and B, it's going to be the same thing. If you see a flame, Clean the flame sense rod, it usually fixes it. If you don't see a flame, check gas.
Because the sequence of operations is pretty much the same on that one.
Yeah, they're pretty much the same from here on out. The only thing's a little bit different is what it does for the blower.
Yeah. We talked about that. All right, so one of the ones I want to talk about is a flammable vapor sensor lockout. Now, that's something that usually you have a reset procedure involved in something like
Correct.
that. Now, there is something different about this water heater that is on the than the IntelliVent, but what does that really mean when that goes out? I know it means that we sense flammable vapors, but
Correct.
really, what does that meaning?
Well, what it means is that it pretty much saved your life in a way like that, because the heater locked out did not ignite flammable vapors. You did not turn into this guy right here on this label.
All right.
But it means the heater has sensed something flammable. It could also mean the sensor has become wet. It's going to be a lot harder for that to happen on this unit, but it means it sensed flammable vapors. Now, this heater, the new 0.70 power vent, is a lot better at this, because what it does is this. If it senses flammable vapors, say it senses flammable vapors because you walked by and you sprayed air freshener, right?
Right.
The fumes are going to dissipate really quick. You know, it's usually going to be pretty quick. If this heater senses flammable vapors, it turns it off. If the fumes clear and the resistance of the flammable vapor sensor goes back down, within 1 minute's time, it automatically resets and takes back off running.
Okay, let's talk about that real quick. We're sensing flammable vapors, and that has to do with resistance on this sensor, correct?
Correct. The sensor is just a resistor, and the way it works is this. If it picks up something flammable, the resistance of it increases. Once it goes over a certain point, it pulls a trigger inside the control valve, which locks the heater out. And it's going to be a hard lockout. Resetting the power, unplugging it, anything like that's not going to fix it. You'll have to do a reset procedure to it. But that's a good way we cut down on nuisance trips on the newer heaters, that if the fumes go away quickly, you know, it automatically resets.
Now, within 1 minute, did you say?
It has to be within 1 minute of sensing or detecting the flammable vapors. Of course, if the flammable vapors stick around a lot longer because you're cleaning your motorcycle chain, you know, right beside the water heater in a bucket of gasoline, you're going to lock the heater out.
Yeah, I understand. Now, you said that there is a reset procedure, so let's talk about that.
There is a reset procedure. So say the heater locked out. First of all, you should not be doing anything with flammable vapors near the heater. Even though it's a flammable vapor design, you never want to test that sort of stuff. It's just not recommended. So if you're going to do anything flammable around it, turn the heater off, or do the flammable activities somewhere else.
Okay.
But yes.
Flammable activity.
Flammable activities, yes. So the first thing to do if you get this code is actually visual check. I like visual checks, just looking around, you know, kind of investigating, see what's going on. Make sure there's nothing flammable around the heater. You know, make sure there's not a bucket full of gasoline with a motorcycle chain in it.
Exactly. Okay.
Make sure there's not open cans of paint thinners, or if you painted your garage floor or whatever. Wherever the heater's located, make sure there's nothing flammable around it, or that you do not detect fumes with your nose.
Okay.
You know, if you do not see any fumes and everything looks good, you can then walk through the reset procedure. Reset procedure on this heater is to turn power off.
Now, if it locks out, do I have to replace this? That's another question we usually get. Before we get in there, yes, I'd recommend replacing it. Now, temporarily, you may be able to reset the heater and get it back up and running. But once that sensor trips, I do recommend replacing it, because it's going to become more sensitive, which means it's going to be safer. Yeah.
But it's going to be easier for it to lock out.
So once the resistance comes down, we have to check that with a multimeter.
Yes.
And make sure that it's in the correct range. Then I can go ahead and reset the water heater.
Well, yeah, I mean, you could do that. That's what a lot of people do. The thing is, if it's not safe to reset the heater, it's not going to allow you to reset it.
Right, okay.
And so it's hard to remember the resistance readings, what everything should read. So that's, if it did trip, replace it. Temporarily, we can usually get it back up and running by doing the reset procedure, but I'd always recommend replacing the sensor once it trips.
Okay, all right.
All right, so the reset procedure is pretty simple, but you have to do it a certain way.
Okay.
It's nothing too involved. So turn the heater off. Turn the temperature knob all the way back down to the vacation setting. So I'm going to turn it all the way down, right?
Okay.
I'm going to turn the power back on, and then wait about 3 seconds, I'm going to turn the temperature up past hot. I'm going to turn it back down all the way. I'm going to turn it up back past hot again, and then it should reset.
Okay. So once you turn it past hot, go back to vacation, and then just set your temperature.
Yes, yes, but it's just always all the way down, turn it up past hot, all the way back down, up past hot, and then it should reset as long as everything's good.
Okay.
But like I said, I mean, even if it does reset and the heater starts working, a lot of people aren't going to do this, but we always recommend replacing the sensor afterwards.
Okay, so if it does trip out, if it does, trip, I guess if it does trip, and you code out on a flammable vapor sensor, you know, it does, you'll have to reset the heater, but you're going to want to replace that sensor if you really do have a flammable vapor situation.
Correct, because like I said, the resistance is never going to go back down.
Now on the IntelliVent, is there anything different on that?
On the IntelliVent, yes, it's different. Of course, the codes signify differently because we have a different way of delivering codes. So in the IntelliVent flammable vapor lockout code is going to be shown by the first light being illuminated and the last light.
Okay.
Now you can turn the heater off, turn it back on, the code's just going to immediately pop back up. So same thing, check around, make sure nothing's flammable, right? If you do see something flammable, remove it, air out the room, all that good stuff. But the reset procedure is similar in its own way. So turn power off, turn it back on. When you turn the power back on, within a couple of seconds, you have to press and hold both the hotter and cooler buttons in at the same time and hold them in until the green vacation light starts to blink.
Okay.
Then when the light starts to blink, let go of the buttons, wait a couple of seconds, press them both in again, hold them in at the same time again until the green vacation light stops blinking and just goes back to steady. When that happens, let go of the buttons. You should see all of them come back on, and then the blower's going to start and the heater's going to reset.
That's where you would set your temperature?
The temperature's going to be at the last point it was.
All right.
And so that's a good thing I like about the IntelliVent is that the temperature is really not going to change. This one, you should always set it back to hot, 120 degrees, unless you have a mixing valve. The reduced risk of scalding, but I mean, yeah, same thing. So.
All right, cool. All right, so so you'll have to reset both of these if you do run into a flammable vapor lockout situation. Then you will have to reset both of them. But the cool thing about the .70 is that if this does lock out, or does sense flammable vapors, if those dissipate within a minute, it's just going to go ahead and reset itself.
Yeah, that's a big design improvement over the IntelliVent. As much as I like the IntelliVent heater, you'd get a lot of nuisance lockout codes on flammable vapors just for small things. With this heater, you will not get that because, like I said, if the fumes go away very quick, it's going to reset itself. So we really dropped that nuisance lockout call down.